Hi and welcome to day 2 of radicals. Today we will be simplifying fractions with radicals or radicals with fractions, however you want to look at it. So when we are simplifying a radical, we need to simplify or separate the numerator and the denominator and simplify them individually. I cannot take the square root of 2, therefore I leave it as radical 2. The square root of 100 is 10. I cannot simplify the 2 and the 10 because the 2 is under the radical and the 10 is not, and I cannot divide the 2. For number 2, I have the square root of 9 over the square root of 49. This one, we look at it as radical 9 divided by radical 49, which is equal to the square root of 9 is 3 over the square root of 49 is 7. For number 3, I would simplify that to the square root of 1 over the square root of 3. Square root of 1 is 1. The square root of 3 is the square root of 3. So, take that back there. Okay, let's try that again. In math, I cannot keep a radical in the denominator. So I need to rationalize the denominator to get rid of the radical. So the only way to get rid of the radical is to multiply by 1 in disguise. And I need to get rid of the radical in the denominator, so I'm going to multiply the numerator and the denominator by radical 3. This right here is 1 in disguise, radical 3 divided by radical 3. So when I multiply, I get 1 times radical 3 is radical 3. Radical 3 times radical 3 is radical 9, and the square root of 9 is 3. So that is my final answer, radical 3 over 3. For number 4, the fraction is out in front of the radical, so it doesn't affect the problem at all. It's just negative 2/3. And I'm going to multiply it by, here, the square root of 27, which is 9 times 3. And the square root of 9 is 3. So it is negative 2/3 times 3 times radical 3. And in this case, my 3's cancel out. Maybe. There they go. And I'm just left with negative 2 radical 3. Number 5 is a little bit different because we have a cube root, remember from yesterday. We need to find the perfect cube that divides into 250 evenly, and that would be 125 times 2. So this is the cube root of 125 times 2, and break down the y to the 7th to y to the 6th times y. So when I clean that up, cube root of 125 is 5. The cube root of y to the 6th is y squared. And then I'm left with the cube root of 2y. For number 6, I'm back to dealing with fractions. I have a negative 10 out in front, which I keep. And then I'm going to multiply it by the square root of 1 over the square root of 2, because I need to break down my numerator and my denominator. So I have negative 10 times square root of 1 is 1 over radical 2. I cannot leave the radical 2 in the denominator, so I need to multiply by 1 in disguise. So I multiply by root 2 over root 2. I'm left with negative radical 10, or sorry, negative 10 radical 2 over radical 2 times radical 2 is radical 4. The square root of 4 is 2. Now I can simplify this again because 2 goes into 10 5 times. So I have negative 5 radical 2 for my final answer. For number 7, I have some choices here. I can choose to simplify the denominator first, radical 12, or I can simplify it second. So this breaks down to radical 1 over radical 12. I'm going to choose to simplify my radicals as I can. So I end up with 1 over 12 breaks down to 4 times 3. And the square root of 4 is 2 radical 3. However, the only problem is I cannot keep the radical 3 in the denominator, so I need to multiply by 1 in disguise, which is radical 3 over radical 3. So I end up with radical 3 divided by radical 3 times radical 3 is 3, because the square root of 9 is 3, times the 2 out in front is 6. Number 8 is a little bit different because I have a cube root. And I need to simplify, and I will take the cube root of 3 over the cube root of 4. And neither one of those is a perfect cube, so I can't simplify them any more than I have. However, I cannot leave a radical in the denominator. I need to somehow make 4 into a perfect cube, or multiply 4 by something that would make a perfect cube. So if I have 4, 4 divides into 8 evenly, and 8 is my smallest perfect cube. And I need to multiply 4 by 2 to make it 8. So instead of multiplying by the square root of 2, I'm going to multiply by the cube root of 2. 2. So I will have the cube root of 6 over the cube root of 8. Cube root of 8 simplifies to 2, and the cube root of 6 cannot simplify, so I simply keep it as cube root 6 over 2. Number 9 is just like number 8, and it's the cube root of 9 over the cube root of 25. I need to multiply by 1 in disguise. 25 is a perfect square, so the square root of 25 is 5. So I'm going to need to multiply this by the cube root of 5, top and bottom, because by doing that, I'll end up with a perfect cube, because that's a square. It's 5 times 5. This is 5 times 5 times 5 now. So I get the cube root of 45 over the cube root of 125. So it's really the cube root of 45 divided by 5. I can't break down the cube root of 45, so I just leave it as it is. Number 10 is back to a square root because there's no number out in front of the radical in the index portion like there was in number 9 and number 8. So number 10 is just simply the square root of 3 over the square root of 8. Can't do anything with the 3 because it doesn't simplify, so it's the square root of 3 over 8 is the square root of 4 times 2. So it's radical 3 over 2 radical 2. Can't leave the radical in the denominator. So we multiply the top and bottom by radical 2. Because my numerators are both under the radical, I can actually multiply them together. So I get radical 6 over radical 2 times radical 2 is square root of 4, which is 2, times the 2 out in front is 4. I cannot simplify this 6 and 4 because one's under the radical and one is not. Now, I told you you could simplify the denominator first or not, and you'd still end up with the same answer. So I'm going to give you an alternative method for doing number 10. So I would start out with radical 3 over radical 8, and I'm just going to multiply by 1 in disguise, which is radical 8. Because they're both under the radical, I can multiply them, so I get radical 24 over radical 8 times radical 8 is 8. I can break 24 down to the square root of 4 times 6 over 8. The square root of 4 is 2. Radical 6 over 8. And the 2 becomes a 1, and the 8 becomes a 4 when I reduce. So it's radical 6 over 4. Both methods are appropriate. Both methods are fine. I don't care which method you choose, just pick one and either stick with it or try to pick the easiest one for that particular problem. For the last one, we're back to a cube root. So we have the cube root of 2 over the cube root of 5. This time 5 isn't a perfect square, so instead of trying to take the square root and multiply it by that, I need to square it and multiply it by that number. So it's the cube root of 25. I need to make a perfect cube in the denominator. The only way I can do that is by taking 5 and squaring it and getting 25. So when I multiply 5 times 25, I get the cube root of 125. My numerator becomes the cube root of 50. And 50 can't be simplified, so it just stays the cube root of 50. And my denominator becomes 5. I cannot divide that 5 and that 50 because the 50 is under the radical and the 5 is not. Now the ones I expected you would have the most difficulties with would be 8, 9, and 11. The other ones shouldn't be so bad. Remember, the key is to multiply by 1 in disguise to get rid of your denominator that has a radical in it, and that's called rationalizing the denominator.